Hello and welcome everyone. So I figured just like always we'd start off with a problem here. So I'd like you to consider this here. We have a picture. I've got AZ here being a tangent to a circle here at this point A, and I have this chord drawn here so that this arc is 80 degrees. We want to find the measure of this angle ZAB. So I'm going to be doing one or two different solutions here. The rest of the solutions we can actually talk about in the classroom, but I'd like you to just consider this here. Pause the video, try this one out on your own first. Okay, so I guess one of the things that we can determine here, there are a couple ways you can tackle this problem here. Note that we have an 80-degree angle here, so that seems to be, that's one thing we can consider, that's an 80-degree arc. We have a tangent here, so it looks like there's going to be a 90-degree angle that's going to be formed here at ZAO, right? So there's your 90-degree angle, that seems fair. Now, we also know that AC is a diameter here, so that's a diameter. As a result, that means this is half a circle here, so that's 180 total. ABC is 180, AB is 80, so that means this has to be what's left over, so BC is 100, right? So we know that the measure of arc BC here is 180 minus 100, which is 80 degrees. So, sorry, the other way around. 180 minus 80 equals 100. That's the other way around, right? Okay, now we note that CAB here, that's an inscribed angle, so as a result, we know that the measure of angle CAB here is 1/2 of 100, or 50 degrees here, right? So that's 50 in this situation. And now we can see that it's pretty clear that ZAB now, ZAB left over, is going to be 180 minus 50, it's going to be 90 minus 50 here. And that yields us a 40-degree angle up there. Okay. So that seems pretty fair, right? So we see that that's the case. So CAB ends up being 40. Okay. So one of the things you're going to note here is that first off, we have the 40 and 80 here. So this is very reminiscent of the inscribed angle, right? The fact that the inscribed angle is 1/2 the arc it intercepts. The same is, it seems like a similar thing is going on here as well. But this time we don't have an inscribed angle because, as you can see, the angle is sort of at the surface of the circle here. We can see that now instead of the angle being formed by two chords, here is its angle formed by a chord and a tangent here. So we have this sort of chord tangent angle as such. So we seem to have this sort of hypothesis here, something that we conjecture is true, that the measure of the angle formed by a chord and a tangent is equal to 1/2 of the arc that intercepts. So this here isn't too hard to prove, ladies and gentlemen. I imagine here that, considering what we just did in the introductory problem, we can do something very similar here too, right? I can go ahead and sketch a circle like so. Let's go ahead and do that here. Here's my tangent. Right, and we can even follow exactly what was set up here. So here's A, here's Z, and then we have ourselves our diameter here. Here's B, sorry, here's C, here's O, and then B is somewhere over here, right? So we can kind of do this sort of thingy here. So note that in this situation here, it makes sense for us to kind of set this up. We're going to let the measure of arc AB equal X. I want to show the measure of angle ZAB is 1/2 X, right? Now, this is pretty straightforward here. We can just do basically the same thing that we did last time, but this time use variables as opposed to just numbers here. And, you know, this idea of abstraction, taking an example and converting it into one that involves variables, it's going to be a useful technique as we go along here, not just in geometry, but other aspects of algebra as well. So we'll let this be X. So it's pretty clear here that the measure of arc BC here, because of the fact that we have a diameter, this is ABC is a semicircle, so it's going to be 180 minus the measure of AB, which is 180 minus X here. So this is 180 minus X. That seems fair. I think that's a clear thing to think about. And we know that this is now we know that the measure of angle BAC here is 1/2 the measure of arc BC here, because this is an inscribed angle. Inscribed angle here is going to be 1/2 the arc it intercepts, so it's 1/2 of 180 minus X, which is 90 minus X over 2. That seems fair. And of course now we know that this is a right angle here on top. Just again, we have ZA being a tangent to the radius AO here, so we can kind of put that in here and say the measure of angle ZAB therefore is 1/2 of, sorry, not 1/2, 90 minus CAB. I'm not doing well today. I'm sorry, ladies and gentlemen. So it's going to be 90 minus, in this case, 90 minus x over 2, right? We can put that in here. So the nice part about this is that when you do your arithmetic like so, we can kind of put this all together. So you get 90 minus 90, and then you have a positive x over 2 here, because in this case we're subtracting a negative quantity. So we're subtracting positive 90 and subtracting a negative x over 2. So you can put this together here. So these drop out, and we're left with x over 2 here, which is what we wanted. So notice that this here kind of demonstrates this sort of fact here, that this here, the measure of the angle formed by a chord and a tangent is equal to 1/2 of the arc that it intercepts. Now, note here, ladies and gentlemen, that this is not the full proof of the theorem here, because if you note, we kind of did this sort of thing here where we had this tangent like this, where you have a tangent like this, you have your AB, and you have AB being a portion of this here. We could also have it, the other way around. I could have this point out here, Y, right? I can do YAB and see that that's 1/2 of BCA here, right? Though, to be fair, I think that we can do something very similar to this here, where we can kind of divide it into two pieces and put it together that way here. So I'm going to leave that as sort of an exercise to you, to show that this proof is incomplete here, and in fact we need to look at some other cases here, but they all function in very similar fashions here. Okay. Now the last thing I want to focus on here is this last bit. Okay. So now we can focus on this here. So notice that, we've been looking at a lot of angles that involve intersections of chords, intersections of tangents, things like that. We said an inscribed angle involves two chords, but that intersects on the surface of the circle itself. It intersects on the circle. Whereas now we can be intersecting inside the circle like this here. So note that we have AD is 60 and CB is 50. We want to find AED. So, well, that's really strange. The hint tells us that we want to draw one more chord. So it would seem that, we're kind of stuck on this here. We're not exactly sure what to do with this. We don't have a lot of our major tools. We don't have inscribed angles. We don't have triangles. We don't have things like that here. We don't even know where the center is. So perhaps here, one of the things, maybe we can try to draw in something that will satisfy multiples of these things at the same time. In particular, if we want a triangle and or an inscribed angle at the same time, it makes sense for us to draw an AC. So if I draw an AC, that actually is going to accomplish two things at once here. Now, of course, you could have drawn in DB, and the argument would be very similar to this here, but it's going to be like this here. Notice how we have ACD here. Now this is an inscribed angle, so this is 60. Therefore, ACD is 1/2 the arc it cuts off, so that's 30 degrees over there. Similarly, CAB like this here, we can see that's a 50-degree angle, so that means this is an inscribed angle here again. So that's 1/2 the arc it cuts off, so that's 25. And now note here that we can note that AED is an exterior angle here, right? So we can see that measure of angle AED here is equal to, in this case, the 25 plus the 30 here, right? Because this is angle CAE plus angle ACE here, right? From that, we can put this together, and we show that's 55 here, right? Okay, so this is 55. That makes sense. Now, one of the things you may note here, wait a minute, this 55 seems pretty straightforward. This 55 seems pretty strange here, in particular with the 60 and 50. You'll note that, unlike the other angles we've been looking at so far, there's actually two intercepted arcs here. Notice how this 55 actually intercepts two things here, right? If we extended the sides of the angles, it hits two arcs of the circle, this arc TA and this arc CB here. And that 55, as you can see here, seems to be exactly smack dab in the middle of the 60 and 50 here. It's exactly half the sum. So this leads us to a conjecture here. We can conjecture this particular theorem, that the measure of an angle formed by the intersection of two chords is equal to 1/2 the sum of the intercepted arc. And again, we can kind of do this here using the same technique we looked at above. So just like before, we can kind of go ahead and draw these out here. Here's AB, and here is CD like this, and we have E here. So just like before, we're going to go ahead and sketch this in here. We want to figure out this angle. Just like before, we'll sketch AC here. We're drawing chord AC. So notice how in this situation, we know that the measure of angle C, in this case here, that's going to be 1/2 the measure of arc AD, right? It's an inscribed angle. So we know that's going to be the case here. Similarly, in this situation here, we can kind of do the same thing in the other side here. So we know that the measure of angle A is going to be 1/2 the measure of arc CB here, which is, again, inscribed. Okay? So, and just like before, we had an exterior angle of a triangle. We can do this again. We know the measure of angle AED here is going to be the measure of angle A plus the measure of angle C here, because this is an exterior angle of a triangle. Right? So this is an exterior angle of a triangle here, so as a result, we can kind of put this together. We know there's going to be 1/2, by substitution, we know it's 1/2 of CB plus 1/2 of AD here, and that we can factor out as 1/2 the two arcs it intercepts. So it's 1/2 the sum of these arcs here. And notice how in this situation here, with this particular angle here, both these angles are vertical angles, so they match up with each other. And they're going to intercept these opposite arcs here. So it's kind of like this. You see that this angle AED here and CBE, this angle AED and CEB here, these two angles intercept AD and CB. They're going to intercept things outward. Whereas if we wanted to focus on, say, AEC here and DEB, they're going to focus on this pair of arcs here. So it's going to be AC on top here and DB down here. So you can see I kind of color-coded the arcs here. So you can see that basically the intercepted arcs are the ones that are opposite each other when you have two chords that intersect inside of a circle here. And as you can see, pretty straightforward here as long as you know how the inscribed angles work and a couple very basic triangle properties here.